All right, so lesson 1.1, stat reasoning. What we're looking at is activity. It's a kind of beginner activity. It gets you to thinking about what we're going to learn today, okay? So what I've had you to do is read what's in the box. And in the box it says, you know, Pepsi's running a promo for the 20-ounce bottles. It says 1 in 6 wins, right? Okay, so this teacher took 30 students to the store to buy 30 bottles. But only 2 of them won. Right? That's what I read. That's what you should have read too, right? So is Pepsi scamming people, or is their claim 1 in 6 wins true? So what do you think?
Only 2 won out of 30. It kind of sounds like it's scamming.
2 out of 30 does seem like it's scamming. But what have you learned in statistics from last year in Algebra 2 that is coming into play?
Bigger groups of are provide more accurate results.
Sample size could be a factor coming into play, right? What would be another one? There's 2 words I'm looking for. Has to deal with the sample size. Size drives these 2 things, these 2 big thoughts. What do you think they are?
The brand?
Huh?
The brand?
The brand?
Yeah. Because of fall. Like, what if they did, like, infected don't get
Oh, what if they, okay, so let's say that everybody had to get a Pepsi.
Yeah.
Because if they chose something else, then it may have been something, you know, a different line that they were produced off, right? So the 1 in 6 may be just for 30 out of 30 Pepsis, right? Instead of maybe out of 30 Mountain Dews, something like that. So the brand could have been a factor, right? Y'all remember these 2 words, actual and theoretical probabilities? Y'all remember that? Just like flipping a coin, you got a 50-50, right? But sometimes when you flip a coin, you hit heads multiple times, right? More so than what would have been 50-50, right? So the actual versus theoretical comes into play in this type problem. So no, Pepsi's not scamming you. 1 in 6 is true, but the sample size does play a factor. The bigger the sample size, the more the actual comes to be what? The theoretical probability, right? So that's what you have to look at. So what we're going to do is, seeing as we can't, you know, I had 30 die lined up, or about 28 of them, 20-something, that I was going to give everybody. But then I would have had to clean all of them, right? Because the second group would have had to do. So look what Palmer did. I went virtual. That's pretty cool right there. I don't care who you are. Okay? So what we're going to do is we're going to roll the dice 30 times, right? Okay? So for the sake of this video, we're going to stop it here, and then we're going to do the thing, and we're going to show the results, and we'll pick it back up. So if you listen to this for the video, we about to pause it, and you about to see a bunch of stuff filled out, okay? So just know we'll be back. Okay, so here are our results of what we rolled out of 30 tries, right? We said the winner was who? If we rolled a 3, we were a winner, right? Okay, so on that sheet, it says make a dot plot, right? Y'all know what a dot plot looks like, right? Well, I'm going to have you do 2 things. Dot plots are good, but we're going to end up making it into a table, okay? And that's why I've got a table here. But dot plots are easy to pivot into a table, all right? So what I mean by dot plot? Well, this right here is what I mean by dot plot. If I was to go, yeah, I can't draw a straight line like that. What's up with that? Let me go over here. For grins and giggles, right? If I was over here, like there's 1, there's 2, there's 3. Dot plot would be like, how many 1s do we have?
4.
Okay, so I'd have like 4 dots, right? Like that's a dot plot, right? Y'all got me? That's also can be transitioned into a frequency table. And this is what this is, frequency table. So you can do the dot plot and then transition into the frequency table, or if you can just make the jump into the frequency table, you could, right? So here's what I mean by a frequency table. Here's my outcomes, correct? You got to, these are the numbers. The numbers of them are going to go right here, right? Y'all with me? Fair enough? All right, so I'm going to let you count. I'm going to pause and let you count and fill in that table. Then we're going to check it. All right? Okay, so what you should have done is you should have filled out here. This is the frequency. So I'm going to do some things right here. I'm going to make this go away because I need to draw some stuff. And you should have already had this already copied down, right? So I need to do this right here. Sorry. I hope you did. We're going to take majority rules. Okay, so here are the items. I might ought to do this. Items, right? Here's the frequency, right? Boy, I can't spell that right. And I did geez Louise, I'm glad I ain't no daggum spelling class. Frequency is how many times it happened, right? Okay, so how many times did we get a 1? 5 times. Everybody agree with that? How many times we get a 2? 3. How many times we get a 3? Really? How about a 4? We got a 4 8 times? Are you kidding me? Man, those bottles would have been stacked, right? If we'd chose a 4, it'd been like, Anyway, what about a 5? So somebody saying 6. Y'all agree or disagree? Yeah? Okay. Y'all quiet on me. How about a 6? How many times y'all get 6? 3? Do those all add up to be 30? Are you sure? Okay, so what we're going to do right here is we're going to, guess what? We're going to make another column. And what that column is going to have is the thing that's called relative frequency. Now, relative frequency can be 2 things. It can be a decimal or it can be a percent. Okay? So how would you calculate the relative frequency? That divided by 30. Why by 30? Okay, so that's the total number we have. What is that? Because that's a pronoun, and if they listen to this, what does that mean? The frequency number. So the first one would be like this right here would be what? 5 out of 30, right? So what is that as a decimal? For what now? 0.16, right? 0.167, right? Got to use your correct rounding principles, right? 5 and up, go up, 4 and down, stays around, correct? So here's what I want you to do. I'm going to give you about 30 seconds to fill out the rest of them, right? You can do a decimal, but go to 3 places. Use your correct rounding. Go. Okay, let's fill in the rest. I'm going to change it to blue. All right, so talk to me here. 0.1? That's it. 0.1. Okay. All right, next. 0.167. What about this one? All right, what about this one? 0.2. What about this one? 0.1. All right, how do I know that those right there are all correct? They should equal 1, or if you put it in as a percent, it should equal what? 100%, correct? Y'all with me? Okay, so let's go back and see if we can answer the question. Is Pepsi false advertising? Are they false advertising? Yes or no? No. We said that, and it was point. Okay, so what is the probability on a 1 out of 6 anyway? What's 1 out of 6 anyway? Well, right, 0.167, right? 0.167. All right. So, and our winner chicken dinner was who? Who was it? 3, right? So right there, right? So our actual and theoretical all matched up, right? But if we'd have chose a 2, would that have been true? No. We would have had to up our sampling, right? Correct? It really depends on how, I mean, if you think about it, when they run these promotions, they have these bottle caps in hoppers, right? They come down, and they got the winners, and then they've got the other ones, right? Sorry, try again. So you would hope that they programmed the line to pull from the winner chicken dinner hopper every 6 bottles, right? 1 out of 6, right? They're pulling from that one and twisting on it, and it's sealed, right? If that's where you could go back and say it and get them if it's false advertising, right? That's what you ought to be looking at. But who checks that? Things that make you go, So, and then they come off the line, they get palletized, right? They go on the pallet, the bit into things, and then they get shrink wrapped and sent to the distribution, right? Okay. So when it's time to go put them in the store, does a store buy a whole pallet? Does a convenience store buy a whole pallet? Really? No, they don't always buy a whole pallet. They may say, give me X amount of Pepsis, right? When they gonna buy a whole pallet, they give me. I mean, if there's 20 Pepsis on a crate, they may say, give me 80 bottles of Pepsi, right? They're not gonna overstock it, correct? They're gonna say, give me a pallet. They're gonna take what they. So they may. I mean, if it's at the end of one, they may be pulling stuff that doesn't have the 1 in 6 in it, right? They could. All their cases could have been ones that didn't have all winners in it, right? Correct? What else do we see that's very similar to that we see every day? But you have to be 18 to play. The lottery. Yeah. Have you ever walked in a convenience store or a place that sells lottery and they have winning tickets placed up around on the wall or up on the board? And then there's some places that sell lottery tickets that don't, right? Yeah? I mean, like, they sell them, but you don't know if they're a winner or not. Why do you think the ones that, I mean, because there's winners at every store, right? Y'all understand that, correct? But why do you think the people that are putting the winning tickets up on the wall, what do you think they're doing? Trying to make you psychologically think that you have a better chance of what? Winning. When in doubt, you got the same chances as that person that walks into the store, the convenience store, that they don't put the lottery ticket winning things up on it, right? It's always, I mean, it creates in your mind more of a perception that you got a greater chance of winning. Because look at all these people win. I could be just like them, right? That's what you say. So it's a mind game that they're playing with you. You never thought about it like that, have you? Yeah. It's a mind game. All right. So everything that we've done right here is really what we're going to learn today. It's the premise of what we learn. But we're going to learn some vocabulary as well, all right? So we're going to move over to the packet that I gave. No, not the packet I gave you. You need to go to notes. You need to go notes. You need to go to notebook. Or if you pulled out your, if you printed out these things, they're called blank teaching notes, then you got these, right? So if you ain't got these, and then you open up your notebook and I will show you what you need to copy down, right? The packet that I gave you right there, it says 1-1 through 1-9, right? That is every activity that you're going to hands-on at the end of the lesson to reinforce what we just done. The single thing was an activator. Fair enough? Okay. So there's a lot of things that are on these slides. A lot of information. I'm going to have you write down certain key things, okay? You with me? So the first thing we need to look at, this is lesson 1-1. This is statistics. It's the science and art of data, right? Here's how I define statistics. I define statistics as the story that the numbers are telling you. It's a story, right? So first thing you need to do is, well, before we do that, we need to understand what we're going to learn. We're going to learn how to identify individuals and variables, and then we're going to learn how to classify the variables as categorical or quantitative, right? We'll do that. And then we'll be able to summarize the distribution of variables with a frequency table. Remember that, what we just done? And a relative frequency. So we've done some of this. We just need to put the rest of the puzzles together. So first things first. Here we go. See this right here that says statistics? That right there? All of that right here needs to be in your notes. Okay? So that's the definition of statistics. Statistics is a science and art of collecting, analyzing, and drawing conclusions from data. I tend to define it as this. It's the story that the data tells you, right? It's the story. It could be a good story, it could be a bad story, or it could be a story that really has no meaning, right? But it is a story. So you need to copy down the definition of stats. I'm going to hit pause and let you do that. All right, now that you know that what the definition of statistics is, let's go look at this. This is the statistical problem-solving process. This is the bigger picture, okay? This is a bigger picture of what we're going to be able to learn and do all throughout the year. This is our goal, okay? We're going to learn how to ask questions that clarify a research problem and be able to ask more valid statistical questions. We're going to learn how to collect data. We're going to design things and carry out appropriate plans to collect it. We're also going to analyze it. We're going to look at tools on analyzing data to be able to see what story the data is telling us. Is it relevant? Does it have statistical significance? Right? We're going to know, or does it really not have anything? Is there no correlation between it? How high of a correlation does it have? Is something driving something else? That's what we're going to do with analyze. Those are tools that we're going to learn throughout this semester. And then interpreting those results. What the heck is it telling us? And can we say, you know what? With so much assurance, we can say this. Or we can say, you know what? We ain't got enough information to be able to draw a conclusion that means anything. Okay? That's where we're going. You ain't got to copy none of that down. Other than you got to know that's where we're going. Yeah? All right. Ready? Here's the other. This right here, individual variable, the definition, the individual, what it means to be an individual, and then what it means to be a variable. Okay? So an individual is a person, animal, or thing that described in a set of data. This is roller coasters, right? The individual is the name of the roller coaster, right? That's the individual item, correct? It has a lot of characteristics, a lot of things based off of that. But it's like one of my favorite ones at Six Flags is a Ninja. I don't know if they still got it or not. I like the Ninja. People get off of it, it hurts. But I like it because the way it turns, it turns and has actions and rolls like a helicopter can do, which is pretty cool. Then you got the Screen Machine. Then you got, what's that one that's a wooden one? Yeah. Oh my gosh, the one that will beat you half to death, George Cyclone. Those are individuals, right? And based off of those individuals, you have variables. A variable is an attribute that can take different values from or for the different individuals, right? Like the type, is it wooden, is it steel? Heights, design, right? Speeds, duration. Those are all variables, correct? The individual is the particular thing that you're talking about, the subject, right? A person, animal, a person, place, or thing, right? You remember that? That's the definition of a noun, right? Definition of a noun. I remember that. Man, that's pretty cool. So an individual is a noun, a thing. All right. So I'm going to let you copy it. Okay, so here we go. Now we're going to look at variables. You know, a variable is any attribute. We just wrote this down, right? We wrote down the definition. But from a variable, you can have categorical or you can have quantitative. And these are the things that you got to know. These fall under the family of who? Variables, right? So what type of variable are you talking about? Are you talking about a categorical or are you talking about a quantitative? All right. Now, the easiest thing to do is say, if it's a number, then it has a 95% chance of being quantitative, right? There are situations where you would have numbers that would not be quantitative. All right. By definition, quantitative variable takes number values for which it makes sense to find an average. So when you ask yourself, is it quantitative or categorical? One, is it a number? And then two, if it's a number, can I take the average of it? And if the answer is yes, then it's quantitative. Okay? If it's not, if it's something else, if it's wordsies and all that stuff, then it's categorical. I'm going to show you right here the one case, the exception, that would be numbers that would be categorical. And it would be something like this. 11-15. What does that represent? Well, we would call it a what? Give me a mathematical term. A range. Good. If you have numbers that are significant or stipulating a range, can you take the average of that? There you go. So that's the exception when you see a number that's not quantitative, right? Now, does that make sense? Is it clear as mud? That's pretty clear, isn't it? Yeah. Okay, I'll pause and let you copy that. Okay, so here we are. We're going to look at this table, and this table right here, you ain't got to copy it down. This table is identifying the type of variable that you have. Okay? Note that Wildfire, Skyline, Goliath, Helix, Barsh, Banshee, good, and then the black hole. Those would all be individuals, right? Right? Those are all individual roller coasters, right? All right. Variables are characteristics of those. So these are all variables. What type of variable? Well, the type is not a number, is it? So it's definitely a who? Categorical. And look at design. There's no numbers in it, then it has to be what? Categorical. Let's look at weight, speed, and then duration. Those are all numbers, but those numbers, if you had to, you could average them, right? So therefore, they would be quantitative. All right, do you see the reasoning, how I'm going through the thought process, how you're determining what is what? Yeah? See, because you don't know what you're looking at, you can't do anything with it. All right, let's go to the next one. Distribution. You need to copy down this definition, okay? A distribution of a variable describes a pattern of variation of these values. Distribution. What does the variable look like? What does the numbers look like? What does the qualitative or categorical data look like, right? How's it distributed? What do you got? You know, what do you got most of? Or what are your options? That's your distribution. Are there a lot more things in one particular type than the other? That's what the distribution is going to tell you. It tells you what, and it also tells you how often. So the key is this. It tells you what, and then how often. That's what the distribution does. So there's a purpose for that. I'll let you copy. Now, we've already talked about this because we did an activity, right? Kind of preview. So what you need to copy down is what is a frequency table and then what is relative frequency. Now, note that it's a proportion or percent, right? I put it, or we put it as decimals, correct? Like 0.123. When you do a relative frequency table, the majority of the time, they will want you to put it as a percent. Okay? Majority of the time. Now, you may come across some that just say leave it as a decimal. And if you do, you need to put it as 3 decimals. And you need to make sure that you started off with a, guess who? 0. And the reason why is there's no way that you can mistake what type of number that is if you start off with the 0. Because a decimal number is the only number that starts with the 0. Period. Does that make sense? Because some people don't put a 0 there and they just put a dot to be your decimal. That dot may be a slight dash or a very faint thing. It's hard to read people's decimals, right? But if you put a 0 in there, there's no mistake about that. So that's good stuff. Then you can take it as 12.3%, right? Does that make sense? You're moving it 2 places. So when you're doing your calculation, go to 3 decimal places and then change it into a percent. So that you have a decimal out there that you're not rounding up or skewing. Because if you were to add that up, if you just took it to 2 and added up, you would come up with a value greater than 100%. So the decimal, that 3rd decimal place, is very important. Okay? All right, so now let's look at the packet that I gave you. The packet that I gave you is the example work that you'll do. It's 1-1 through 1-9. So we're on 1-1. This is a staple one, right? Okay? If you have blank teacher notes, it's already built in, right? It's there. But they're giving you a table, and they're asking you to classify it as, let's see, they want you to classify it as categorical or quantitative, right? Now, I want you to pay attention to this last row. See that last row? It's blank, right? So if I were you, I would take advantage of that last row, and I would put my answer in that. Now, what would my answers be? Huh? C for categorical, Q for who? Okay, quantitative or quantitative, right? So take about 30 seconds and see if you can identify what type of variable each column is. Go. Okay, ladies and gentlemen. I'm going to go blue. All right, so gender, is it categorical or quantitative? C or Q? C. What about class? GPA? Why? It's numbers. What? Average. Good. What about Q? Good job. How about that one? Good. Q. C. Why? It's a range. Good. What about this one? Q. What about that one? How about identifying variables? How comfortable do you feel with identifying variables? Yay or nay? Yeah? Is it making a little bit of sense? Or is it, you wrapped your mind around it? You clear you can do it? Sweet. The next thing that we have to do is this. Here is 40 students in a class. Summarize the distribution of their ages with a frequency table and a relative frequency table. So here's the frequency, and here's going to be the relative frequency, and we're going to do it as a what? Percent, right? That means you got to go to 3 decimal places and then convert it to a percent. Y'all with me? Okay, so you got to identify what this right here would be the lower bound. This would be the what? Upper bound, right? The lowest number in a relative, in a frequency table, the lower bound's here and upper bound's here, right? So you got to identify who's the lowest number and then how many you got, right? So I'm going to give you, what, about a minute? Yeah? I give you a minute. Now, always make sure that these numbers right here add up to who? 40. Right? And then make sure that this number adds up to what? 100 what? Percent. So let's see what you can do. You can use your phones right now as calculators. Go. All right, here we go. If you're still working, you should be far enough along. You're probably in the decimals and all that other stuff, right? So I think my lower bound is what? 14. I'm about to change some colors. Let's go here. Then I go what? 15, 16, 17, what? That's my distribution, right? Aha, y'all see that vocabulary word? What's my numbers look like? That's my distribution right there. Okay, now frequency. Let's go to green. How many 14s did we have? Are y'all agreeing? What about this one? 15. How many?
4.
This one? 9.
17.
Ooh, 17 17s. How about them taters? All right, how many 18s?
5.
Good. Does that add up to be 40? Then you've probably done it correct, right? Okay, now let's talk about relative frequency. That is a fraction. That is a part over what? Whole, right? 5 out of how many?
40.
Right, 5 out of 40, right? What does that give me as a percent? 12 point what? Right? 12 and a half, right? 0.125 is a decimal, right? Yeah? What's 4? 10%, right? Yeah. That makes sense, right? What about 9? 22.5%, right? 17? 42.5? And then 5, I guess, we've already done that one, right? Do those all add up to be 100%? Yes or no? Okay. Now, ladies and gentlemen, that is the lesson for 1-1. Okay? That is looking at statistics and being able to understand, is it categorical or what? Quantitative, good. Can you organize the data to see its distribution and look at it in terms of a relative frequency? Those were goals that you had. If you think about it, that was in this lesson, we should be able to do this and this, right? So we did, right? Correct? Okay, now, you're prepared enough that you can go on and do your homework. But for us, it's 11:56. We got about 3 minutes before we go to lunch. So that's the end of the lecture for today.